Alright, let's determine the equation of the tangent to y is equal to negative x over x plus 1 squared at x is equal to negative 2. So if we want to find the equation of the tangent is, well, we know that tangent is a line, so it should be in the form of y is equal to mx plus b, right? Now, we want to find two things out of this equation. We need to find the slope of the tangent and the y-intercept, right? Now, in order to do this, it would help us to have a point. We know that x is equal to negative 2. I'm going to find the equivalent y value to this point. So if I plug this in, I'm going to call y f of x. So I'm going to do f of negative 2 to find its equivalent y value. So we have negative 2 over negative 2 plus 1 squared, which is 2 over negative 1 squared, which is 2. Okay, so our point here is negative 2 and 2. So this is the point that the tangent is going to hit. Now, in order for us to find the slope of the tangent, we need to find the derivative function, f prime of x, but we're specifically finding the slope of the tangent at x is equal to negative 2. So we're basically finding f prime of negative 2. So f prime of negative 2 just means the slope of the tangent at x is equal to negative 2. So let's find the derivative function. So f prime of x here, we know that f of x is equal to negative x over x plus 1 squared. To find f prime of x, I'm going to be using the quotient rule. So I'm going to do derivative of negative x. Oops. Negative x. So derivative of numerator times the denominator, x plus 1 squared, minus the derivative of the denominator times the numerator, negative x. I'm going to put this over to the denominator squared, so x plus 1. If you square x plus 1 squared, you get x plus 1 to the power 4. Okay, if I clean up the numerator a little bit, we get negative 1 times x plus 1 squared minus, you're going to be using the chain rule here, so 2 times x plus 1. Because the derivative of the inside of this is 1, we don't have to write it, times negative x. And if I simplify this, I'm going to factor out an x plus 1 here. So if I factor out an x plus 1, we get negative 1 times x plus 1 times negative 2 times negative x. And this is going to give me x plus 1 times negative x minus 1. So I'm going to expand this guy out. So it's always good to kind of factor this out because it will make our expression more simplified and it's easier to work with. This is x plus 1 times negative x plus 2x, which is x minus 1. Okay, so this is what the numerator looks like. So our derivative function f prime of x should be x plus 1 times x minus 1 over x plus 1 to the power 4. Now at this point, I'm just going to simplify this a little bit. So I'm just going to move it over here. So if I simplify this, I can divide the common factors. This is power 1, this is power 4. So we basically have f prime of x minus 1 over x plus 1 to the power of 3. Okay, so you want to find the slope at this point. So I'm going to do f prime of negative 2. Okay, so you want to find the slope at negative 2. So f prime of negative 2 is negative 2 minus 1 over negative 2 plus 1 cubed, which is negative 3 over negative 1 cubed, which is positive 3. Okay, so f prime of negative 2 is positive 3. So the equation here is y is equal to 3x plus b. Okay, you want to solve for b now, right? We have the slope. If you want to solve for b, I'm going to substitute a point because we know that a tangent only passes through a single point, and any point that passes through a line will satisfy the equation of the line. So we're going to substitute the point negative 2 and 2 because that's the only point that actually passes, that this line will pass through. So if I plug this in, we basically get 2 for y is equal to 3 times negative 2 plus b, and this is going to give us 2 is equal to negative 6 plus b, b is equal to 8. So therefore, we have b is equal to 8, we have slope is equal to 3, so the equation of the tangent, therefore, is y is equal to 3x plus 8. Okay, so that is the equation of the tangent to the point x is equal to negative 2.